Let's work this problem. I want to find dy dx. Got x squared y to the third minus 5x is equal to 0. Now I'm going to take the derivative of everything where it's sitting. So we'll take the derivative with respect to x of x squared y to the third minus derivative with respect to x of 5x equals the derivative with respect to x of 0. Now it doesn't matter where you put the negative at. You can put it out in front if you want, or you can put it inside the parentheses. You need to keep track of it so you don't lose the sign, whatever manner that is. So this right here is a product rule. We got something times something else. So that's our p and that's our q. Now we need p prime. The derivative of x squared is 2x. We also need q prime. The derivative of y to the third with respect to x is 3y squared. Take your power, put it out in front, lower it by 1. But since we're taking the derivative with respect to x and it's really a y, we have to put on a y prime. Now our formula is p prime q plus p q prime. Well, p prime we said was 2x times q, which is y to the third, plus p, which is x squared, times q prime, which is 3y squared y prime, minus the derivative of 5x is 5 equals the derivative of 0 is 0. Okay, so that gives us 2x y to the third plus 3x squared y prime minus 5 equals 0. Now we want to solve for y prime, and I went through these steps in class. First step is get rid of parentheses, don't have any. Second step is get rid of fractions, don't have any. Third step is get everything with p prime on one side, everything else on the other side. So I'm going to take this negative 5, move it to the right side. I'll take this 2x y to the third and move it to the right side. So that gives us 3x squared y prime equals 5 minus 2x y to the third. Step 4 is to, if the y prime is in 2 or more terms, factor it out. It's not. It's only in one term. They don't even have to actually be terms. Step 5, divide both sides by what's in front of / back of the y prime. Well, there's a 3x squared y squared in front of it. So we'll divide both sides by 3x squared y squared. There you go. And do the same thing over here. X squared y squared. Well, over here the 3's cancel, the x squareds cancel, and the y squareds cancel. And we end up with y prime is equal to 5 minus 2x y to the third over 3x squared y squared. And that's our answer. Now, just for fun, I've done this on the last two homework problems, and I'll do this is the last one I'll do it on. I swear. You're probably getting tired of seeing it. It might even be the last one I can do it on, feasibly. But let me solve for y first. So I'm going to take the negative 5x to the right side. So we got x squared y to the third is equal to 5x. Then I'll divide both sides by x squared, trying to get the y by itself, over x squared. Those cancel and gives us y to the third is equal to, and that's 5 over x. Now I can take both sides to the 1/3 power. So 5 over x to the 1/3. Those cancel and gives us y. And way back when you have a inside your parentheses everything's multiplication or everything's division, you raise it into a power, you can take everything to that power. So we'll take the 5 to the 1/3 power, and we'll take the x to the 1/3 power. Now 5 to the 1/3, that's the cube root of 5. So we write it back in that form. This x to the 1/3, though, I'm going to take it and move it up on top. So take that, move it up on top, and it becomes x to the negative 1/3. And now we're ready to find our derivative. Take the negative, well, if you got x to a power, you take your negative 1/3, take your power, put it out in front. So we got the cube root of 5 times negative 1/3 x, and then you lower your power by 1. So negative 1/3 minus 1. So then we get the 5th root of 5 and times negative 1/3, and that's x to the negative 4/3. Well, I'm going to merge this all into a single fraction, so I'll put the negative cube root of 5 up on top. 3 goes down here, and this is x to the 4/3. Now you might be looking at that and think, really? That's going to equal the other side? Well, let's see. Try to pick the appropriate place here. I guess right here is as good as any. Here we said y is equal to the cube root of 5 x to negative 1/3. Well, let's take that. Like this right here, and let's plug that in for y at this point and see if we can get to simplify to look like that. Okay, so we're going to have 5 minus 2x, and then we'll have the cube root of 5 x to the negative 1/3. We're replacing the y with this to the third power. And down here we'll have 3x squared, and then the cube root of 5 x to the negative 1/3 to the second power. To be honest, I'm having trouble seeing this myself, how that simplifies, but let's see. Now, if everything inside your parentheses is multiplication and division, you're raising it to power, you can take everything to that power. So we'll take the cube root of 5 to the third power, and we'll take x to the negative 1/3 to the third power. So we're going to have 5 minus 2x times, and then we got the cube root of 5 to the third power, and we have x to the negative 1/3 to the third power. Same thing down below, so this becomes 3x squared. I guess that's a minus. And then we'll have the cube root of 5 squared, and then we'll have x to the negative 1/3 squared. Okay, so we got 5 minus 2x. When your index matches the power you're raising to, they cancel each other out, so that leaves us 5. Here, when you raise one exponent to another exponent, you can multiply them together. 1/3 times 3 gives us 1, so that's negative 1. So this is x to the negative 1. Down here, let's see, this right here gives me 5 to the 2/3 power. If I put it back in the rational exponent form, fractional power, and this is x to the negative 2/3. Oh, where can I go? I guess right here. I've got room for one more step. Okay, negative 2 times 5 is negative 10. Now x to the first power times x to the negative 1 power. Since it's x to a power times x to a power, we'll add the exponents. 1 plus negative 1 gives us 0. So x is 0 drops away. Okay, down below here we got 3x squared, and then 5 to the 2/3, and then x to the negative 2/3. Okay, 5 minus 10 is negative 5. Then 5 to the 2/3. There we go. Now here we got x to a power times x to a power. If you got x to a power times x to a power, you add the exponents. So this is going to be 2 minus 2/3. When I say add, that's like 2 plus a negative 2/3. And that should be a times here. There we go. Sorry about that. Up on top, that's like negative 1 times 5 to the first over 3 times 5 to the 2/3. And this gives us 4/3. So x to the 4/3. It's starting to shape up. If we have, I can rewrite that. 5 to the first, that's like 5 to the 3 over 3. This is 3 times 5 to the 2/3. X to the 4/3. If you got 5 to a power over 5 to a power, you subtract a smaller exponent from a larger one. You subtract a smaller exponent from a larger one. 3/3 minus 2/3 gives us 1/3, and we'll have 5 to the 1/3 where our larger exponent was, which was on top. Let's see. There we go. There we go. Now 5 to the 1/3 is a cube root, so that's negative cube root of 5, and then this is 3x to the 4/3. And you see, as bizarre as it seems, that actually does simplify to what you would have got going the other direction. Again, I don't require you to go through all these steps here to simplify. I'm happy with this answer right here. This 5 minus 2xy to the third over 3x squared y squared.